All right, guys, are there any questions on any of the assignments thus far? What we're looking at today is isosceles and equilateral triangles. Isosceles and equilateral triangles. Isosceles, a triangle is isosceles when at least two congruent sides. It has at least two congruent sides. Now, in an isosceles triangle, the angle formed between the two congruent sides is going to be called the vertex. And the side that's not congruent to the other two is going to be called the base. So in an isosceles triangle, the non-congruent side is called the base. Now, the two angles that connect to the base are called base angles. So the two side angles that are connected to the base are called the base angles because they're connected to the base side of the triangle. Any questions on this so far? So this is the base, and these here are base angles. They're the base angles. Now, our base angle theorem states if two sides of a triangle are congruent, then the angles opposite those sides are congruent as well. So in an isosceles triangle, the base angles are congruent. They're going to be the same. Now, the converse of this is true. If two angles of a triangle are congruent, then the opposite sides are congruent as well. So if I have two angles in a triangle that are congruent, the sides opposite those angles will be congruent as well. If we have two sides in a triangle that are congruent, the angles opposite them will be congruent. Questions on this here? In triangle DEF, side length DE is congruent to side length DF. Name two congruent angles. So angle F would be congruent to angle E. Because the angles opposite those congruent sides will be congruent. So angle F and angle E would be congruent. That's it. Yeah. Yeah. Does it name two congruent angles? Well, those two angles are congruent.
Okay, what is that?
Yeah. Because since FD is congruent to ED, it means that the angles opposite those, F and E, would be congruent also.
What's that triangle mean?
Huh?
That triangle in the DEF.
Because we're saying that it is a triangle.
Oh, okay.
In the figure, angle A is congruent to angle B. Name two congruent sides.
A and B.
So the sides opposite those angles would be congruent. So A, C, B, because AB would be the base. Because the side that connects the congruent angles is going to be the base. The other two sides will be the two that are congruent. Questions on this here? So let's fill in the information so that we can see it a little bit easier, because they didn't give us any of the side lengths marked, which ones are congruent. Now it tells us that HG is congruent to HK. Now we just need to name the angles that are congruent. So angle G would be one of them. Now the other one would be at K, but how many angles are at point K? 2, so we need 3 letters. So H, K, H, K, because there's 2 angles here, because we have an angle here and an angle here. Whenever we have more than one angle, we've got to use the 3 letters. Because at point G, there's only that one angle there, so we can name it by its vertex. Because when we name an angle, we can either name it with the 3 letters, with the vertex in the middle, or we could have named it as G, K, H.
But you have to have K in it.
Yes. To name this angle here.
So it's like that. What about something?
Yep. Because we also have H, K, J.
Oh, that's a whole different triangle.
Those are 2 different angles. Because there's more than one angle at point K, yes? Well, there's this angle and there is. HKJ would be this one here. We need that one over there. Because we said that these 2 were congruent, so it means that this angle and this angle are congruent. HKJ would be this one over here, not the one we want. Which part? Because we can't name K by a single letter because there's 2 angles there. We could have said HGK for the other angle also. But because there's only one angle there, we can name it by the vertex.
So if there's just no triangle and J wasn't there, that would just be K.
Any other questions on this here? Let's look at the next one. If angle 8 or KHJ is congruent to KJH, then what's congruent to what? So KHJ, so this angle here is congruent to KJH, would be this angle here. So what we're saying is that these 2 angles here are congruent to each other because we're just tracing the angle out. So KHJ, KHJ would be this angle here. KJH would be this angle here. Questions on this here? Okay? So these are naming the angles, and we trace it out. So KHJ. So where does it start? Goes to? So we're talking about this angle here. We're just talking KJH. So these 2 angles are? So this one here is congruent to. Now the sides opposite them so the sides would be KH, and the other side would be? Or JK. Yes. Any other questions on this here? If a triangle is equilateral, well, equilateral means what?
Equal.
All of what are equal? Sides. Lateral is going to be our sides. Then it is equiangular. So this is saying, the first theorem is saying, if it is an equilateral triangle, if all 3 sides are the same, it means it is also equiangular. So all 3 angles are going to be the same. The converse, if a triangle is equiangular, if all three angles are the same, then it is equilateral. So if a triangle is equilateral, then it is equiangular. If a triangle is equiangular, then it is equilateral. If we have one, we have to have the other. They always go together. So if we look at this here, this first triangle, we're told that all three sides are the same, yes? So that means it's an equilateral triangle, which also means all three angles are the same. Now, we could solve this out and just call each angle x, because if all the angles are the same, they will have the exact same measure, so we can call them all x. And we know that any three angles in a triangle added together will always equal 180. So x plus x is, there's x. To get x by itself, we would divide by 3. So x is equal to 60. So we could say that the measure of angle P is the measure of angle Q, and the measure of angle R is, because all three angles are going to be the exact same. And really it's going to work out that in any equiangular triangle, the three angles are all going to be what? 60. They're all going to be 60 degrees. Because that's the only way we can cut 180 degrees or 180 into three equal pieces, is if all three pieces are 60 degrees. Any questions on this here? Find the length of ST. How about SU? Because here it is equiangular, and if a triangle is equiangular, it also means it's equilateral. So all three sides are the same. Huh? No, because we're talking about the measure of the angle. So we talk about the measure of the angle, we don't need the line because we're talking about its length. If we're talking about the line itself, then we do need it. And what would the measure of each one of these angles be? Because if it is equiangular, all three angles will be 60 degrees. Find the value of x. Now there's two different ways we can go about this. Now since it is equilateral, it means all the angles are going to be the same because it's also equiangular. So we could call all of these 2x. And we can say 2x plus 2x plus 2x is equal to 180. Because we can add all three angles together and they will equal 180. Well, 2x plus 2x plus 2x is equal to 180. Divide both sides by 6 and we get x is equal to 30. Now, what did we say each one of the angles in an equiangular triangle will be? 60. So we're also saying, would say that 2x is equal to, divide both sides by 2, we get x is equal to 30. Either way it works. Because of the fact that we knew that each angle in an equiangular triangle would be 60, we could have just set 2x equal to 60 and solved and got the same thing. It'll be dealing with these here, yes. Any questions on this here? We have 3 problems left. these here are combining both equiangular and equilateral triangles with our isosceles triangles. So the best thing to do, and what I would do first, is fill in what we know. Yeah, y equals 4. Because when we look at this here, it is equiangular, so it also means it is equilateral. All three of these sides are going to be the same. So y is 4. Those are the same. Now in the other triangle, we have two angles that are equal. So the sides opposite those angles would also be the same. So these two sides would be the same. Well, since one of the sides already has one mark on it, the other will just have 1. So what does that mean? All of these side lengths are what? So x plus 1 is? Subtract 1 from both sides, and we get x is equal to? Yep, as we found x and y. We're ready for the next one. Okay, turn the page. And that decides to stop. Yes. So we can say that we would divide by 4. Since this triangle is equiangular, it is also equilateral. All three of those sides would be the same. So each one of those would be 28. Because all three of these sides are the same. Now these two sides are the same, so the angles opposite them would be, so this angle and this angle would be the same because the sides opposite are the same. Now, what are our three angles inside the equiangular triangle? 28. Because in an equiangular triangle, each of the angles would be 60 degrees. Now 2x and 2x in the other triangle are our angles. Now if I knew what this angle was, well, 2x and 2x and that angle would add together to be 180, yes? Well, what does 60 and this angle here do? They make a, so they add together to be. So to find that angle, I can take 180 and subtract what? Questions on this here? Okay. Which part? Why these are 60?
Oh, why they're 60 is because 60 times 3 equals 180.
Okay.
Hey, if we're trying to find the values of x, why do we do that?
Huh?
If we're trying to find the values of x, why do we do that?
So if we take all this out, let's.
I understand how to walk. I don't understand how to dance.
So x is this angle, yes?
Yes.
What other angles do we have to relate to it? Well, we know this is 28. These two sides are congruent, yes? If we have two congruent sides in a triangle, the angles opposite them are congruent. Yeah, so this angle over here would be 2x, because 28 is the side lengths, not the angles. Because 2x is the angle. Because 2x degrees here, 2x is this angle here.
And 4y isn't the angle.
4y is our length. because 28 is the length of the line, not the degree of the angle, because we have 2x degrees. Well, we know 2x and 2x are the same, yes? Now, inside this triangle, all three angles add together to be what? Okay. So I do have 2x plus 2x plus, what is the third angle? What would be that angle there, yes? Do we know what that angle is? It's 120. Because this angle over here is, let's do it in a different color, 60, because each one of the angles in this here are 60 because it's an equiangular triangle. Now, since we know this angle is 60, and these two angles here make a straight line, any two angles that make a straight line add together to be 180. Because of our linear pairs, two angles that make a straight line add together to be 180. No, we are. So we're finished getting that because we're setting it up at this point. So it would be 120. Now, to finish solving for the value of x, well, 2x plus 2x is plus 120 equals, yes, we would subtract 120 from both sides, which would tell us 4x is equal to, almost. Yeah, 60 divided by 4 is?
I have a question.
Yeah, because we're not dealing with 28. 28 is the side length. Yes, sir.
Okay, at 28, like, is it to be, like, what is it? Is it 28 feet? 28
Yep.
degrees?
It's length. It is the length of the side.
So feet.
Yeah.
So since it's a line right there, and that side's 60, this one goes up 160.
Because that angle is 60 degrees, so this one has to be 120. Yes. Let's look at the next one.
Wait, can you go up on that? If that one's 120, what are the other angles?
The other angles would be,
So does that 28 actually matter?
30.
it's the length of the line. So the distance from here to here is 28. 28 is the length of the line.
They're both 30.
All right, guys. Let's look at this one here. This one here is the last one that we have that we're going to do. Now, let's identify the parts that we know in each one of these here. Since this one triangle, this triangle here, all three sides are the, so each of the angles would be the
60.
same, but more specifically, each one would be,
60 degrees.
so x is in an equilateral triangle. We also have an equiangular triangle, because if a triangle is equilateral, then it is equiangular. And if it is equiangular, each of the angles would be 60 degrees. In our other triangle, we have that these two sides are congruent. And the angles opposite congruent sides are congruent, yes? So it means that these two angles are congruent to each other. And really we can put 2 markers because they're not going to be the same as these here. Now we know that y plus whatever these two angles would equal 180. Y plus equals 180. Now I do notice down here that they tell us what? This angle is, the whole angle is 90. Well, part of it's 60. So this angle has to be
30. So the other side's 30. And then that means the middle would be 120.
So we can solve it and check and see. So any questions on how we set this equation up?
No.
30 plus 30 is? Equals?
Got your,
Huh?
got your piece.
Yep. And that's really with these here, setting up and seeing what is congruent and what's not first will help. So when we start matching things up, we can see what is going to be congruent, what's going to be the same. Questions on this here? Okay.
So since that was 60, that left 30 over, and since these two are congruent, it would make both sides 30.
Both angles 30, yes. Yes. Yeah, because we're talking about the angles there. Like on the last one, we were talking about the side lengths being 28. Then we looked at the angles.
I understand this one better than that one.
Yeah, because here,
This one I don't understand at all.
because we're saying really that this is 28. This side length is,
28.
so we're talking about that length. So it's really saying that these two, all of these are congruent, yes?
Mhm.
Since these two are congruent, it means these angles are, so this angle is,
2x,
so really up here, we have a triangle that has 2x and
2x.
now we really need to find that angle. Well, this angle here is right here,
Mhm.
and the angle next to it is,
60,
these two angles would add together to be,
80.
so it is. Does that make sense?
So I understand how to get that part, just find the equation.
Yep,
Get back today.
and that's how we do that. All right, guys.
Get back today.
So your homework is on page 232. Problems 3 through 10, 13 through 16, and 19. Do we feel pretty comfortable with what we've done this week? Thank you. Yes? There is a quiz over 5.1, 5.2, and 5.4 on Monday. Going over what we did today, yesterday, or all this week. On Monday.